In this video, we will explore line following robots and their algorithms, test them in Python, and help you choose the best ones for your project. I am Mr. Tambo, and stay tuned. The first and most used algorithm is the PID control algorithm. It uses three major components to keep the robot on track. We have the proportional component, the integral component, and the differential component. Together, these three components work on the present, past, and future errors. They make sure they keep the line following robot on track, constantly adjusting its movement based on these error calculations. Fuzzy logic. It works with degrees of uncertainty. If the line is a little bit off, turn slightly, just like human beings. For a line following robot, it tweaks motor slightly to avoid wobbling. Neural networks. They take sensor values and map them directly to motor speed through hidden layers that learn patterns from training data. They are not fixed values, just smart pattern matching. This keeps the line following robot smoothly on track by instantly adjusting motors to curve or shift. Cutoff maps. Based on the states of inputs, the robot will determine its direction on the track it is following. We pair up ones of sensor readings to come up with a rule for the robot to follow. Now you could minimize some kind of jerky bang bang motion on the track based on the number of inputs you supply to the robot. So the more inputs, the smoother it's going to move. And now to something much more advanced, artificial potential fields. For us to understand this, we need to understand some basic concepts like electrostatic forces. Like charges will always repel, while unlike charges will always attract. This is Coulomb's law. And this law also states that the force that is exerted during this repulsion or attraction is inversely proportional to how far they apart. So the higher the distance, the lower the force. Let's look at that on the graph. So if we reduce the distance, we increase the force exponentially. If we reduce the distance, the force reduces. In artificial potential fields, the goal of the robot applies an attractive force, and the obstacles will always apply a repulsive force from the robot. I'm pushing it towards the goal. Now applying this to line following robots, the track will exert an attractive force on the robot. The sensors will exert an attractive force towards the track, and the space where there is no track will exert a repulsive force. Now, looking at this visually, the track has a negative potential, the sensors positive. This will always have attraction and repulsion interaction between the sensors, the track, and the open space, keeping the robot always on track. Let's see this better by giving each sensor weights. The weights come in place to give the wheels a certain degree of control based on the inputs from the sensors. So now we are done with the algorithms. Let's see how we could implement that in Python. Build this virtual environment for testing these algorithms. It's not really difficult to do it, with the advent of AI and prompting. ChatGPT was used to come up with this environment. As you can see, it's just by prompting. GPT does the rest for you. I really love this cool feature where I could hand draw my own tracks. So that you hit your S key to save and look that later. So these are the tracks I've hand-run before. And well, you can test the algorithm now. So I'm going to let this play so you could watch, see how the algorithm functions. Now, if you notice on the track, there are dots that turn from blue to green. And these dots are there to apply a correction. This is to avoid the robot from going backwards. So it got a little bit stuck here due to the track was too difficult and I couldn't take that turn. So I used the slider to increase the speed so I could, escape from this. But it definitely made it out of this situation. Yeah, so thank you guys very much for staying tuned to this, and thanks for your support. If you want more of content like this, you could leave a like and subscribe for part 2. We'll build it physically.